Just to make sure whether is it full screen. Can you hear me?
Yeah, I think it was full screen, and we can hear you.
Can or cannot? Sorry.
We can hear you.
If you're referring to the slides, it's not full screen. You can see the browser window and the menu in Google Slides.
But this?
Yeah, now it's full screen, yes.
Hello, can you hear me?
Oh, yes.
Yeah. Do you have any video you want to share?
No.
No. Okay. Okay. I will remind you before 5 minutes of your end of your talk
Okay.
through
No problem.
the chat. Yeah, through the chat.
Okay. Hi. A very good afternoon to everyone. Welcome to my session. So I will be the presenter for today. My name is Pei Sing, and today my topic will be data and label efficient learning in an imperfect world. So I would like to give a brief introduction about myself. So currently I am the artificial intelligence research and development engineer in VTROX Corporation Parks, and I currently as I'm the Malaysian Human Resource Development Certified Trainer as well. And at the same time, I pursue my PhD study in University Technology Petronas. So before I share the main topic of today, basically I would like to give you a introduction about what is AI, what is machine learning, and what is deep learning. So basically, any technique as long as it's able to enable the computer to mimic human behavior, so we can call it as a artificial intelligence. So you can think about artificial intelligence is like an universe, and inside the universe, right, there are multiple categories, and one of the category is called machine learning. machine learning is defined as AI techniques that give the computer the ability to learn without being explicitly programmed to do so, meaning that it contains the capability to learn from the data without purposely specifying the rules and so on. So this is machine learning. And so the example of the algorithm are like KNN, decision tree, and also the naive Bayes. Whereas like the fuzzy logic, particle swarm optimization, PSO, they are actually the artificial intelligence algorithms, but they are not the machine learning algorithms. And then deep learning basically is a subset of machine learning algorithm where it makes the computations of multi-layers neural network feasible. So meaning that deep learning is a subset of machine learning where it can handle more complex tasks like the image data, the image classification, when talking about the natural language processing, so on. Okay, so the example of the networks is the CNN, convolutional neural networks. Today focus will be more on the machine learning and also the deep learning. So we are not talking about the artificial intelligence. Okay. So next, so in order for you to train machine learning or deep learning models, so you will gone through these processes. So first, we actually separate the process into three. So first one is more on the data management side, and the second one is more on the experimentation side, and thirdly, of course, is the production. So in the data management side, basically we need to manage the data we have collected. So of course, in order for you to build a model, of course you need to collect some images. So after you collect some images, then you need to do some preparation on it. So like a simple processing, for example, like resizing. So why we want to do so is um, because if you put, let's say your image size is around 1000 pixels by 1000 pixels, so this image size is very large, and then if you train on such image size, right, you will require a very powerful GPU, and of course it will take longer time. So that's why sometimes in the deep learning, so we will resize the images probably down to around 224 by 224 with height, so that it will make the training process faster. At the same time, the accuracy are able to be okay. And then next, we will have after we prepare the data, then of course we need to develop the model. So basically, we need to think about what type of a model architecture we want to use. Then after that, we will go for training. So the training process basically means that the model will start to learn from the data, and then basically to capture some knowledge from the data, so they're able to perform some tasks. So after we make we modeling, after we perform the modeling, of course, we will check the accuracy. So we want to know whether how was my model performs. So whether it's good or bad. So at this part, right, we are going to perform some accuracy measure based on the part of the data we have collected. So meaning that we train on one portion of our data, then we test with another portion of data. So this is a common approach in machine learning workflow. Then so if we think that this model is performed good enough, then we'll go to the production, meaning that we deploy the model, we let the model to be run in the production mode. So the data management and also experimentation, they are actually the development work. And then after the model, everything have been fine-tuned, have been well developed, then we're going to bring to the production so that they can run to improve the process. And then in the production, of course, we need to have some monitoring and also the alerting mechanism. So in case the model goes wrong. Okay. So I think you saw some arrow here. So meaning that if the accuracy is not reached, meaning that during the training, right, if the accuracy is not meet your requirement, of course we need to improve the model. Basically, either we adding more images or we try to use some tricks, okay, so that we able to make the model to be more outperform. Or during the production, right, you found out that probably the model is not perform that you expected. So probably what you need to do is that you either need to retrain the model, meaning that using the same data but you improve on the model side, or you try to fix the data drift. So data drift here basically means that when across the, because your model is learned based on the past data. So when the new data coming in probably across the time, right? So the model might not be very accurately predict based on the current data. So that's why you need to probably add more current data so that able to improve the performance. Okay. And so just now I explained to you is about the workflow, basically the flow in order for you to train machine learning models. And of course, there are challenges in each of the stage. So for example, data unpredictability, meaning that I cannot get the data that I wish. So here I try to segment the problem into a smaller piece. Like for example, your user probably will say like, I don't have enough data to do machine learning, or I don't have enough labeled data, meaning that he got data, but the data is not labeled at all. Or sometimes the data set is really unbalanced, meaning that you may have some of the class that contain a large amount of the samples, whereas some of the class actually just a few samples. So this is what does my data unavailability here means. And then of course, in the data preparation side, so we may face the issue of unknown optimal data processing technique. So meaning here that we don't know whether if we do this operation right, was yeah probably would be resizing, cropping, and flip. Will it affect the modeling process? So yeah, this is something we need to take care of, and then we need to find the most optimum settings. And for the tabular data, of course, you need to do some feature selection, probably to just to improve the model. If you try to remove some feature, probably the feature that you remove is not really important, but you don't know. Okay, so you need to. This is a challenge you will face. Okay, at this stage. And of course, in the model development, you need to select the optimum network architecture as well as the modeling hyperparameter. So yeah, basically you need to go through a few set of the training and validation, then you will be only able to know which setting work the best, okay, for your current data sets. And in the prediction side, so probably now you know that your okay after you develop your model, right, you know that your model performance is good on the accuracy side. But there's another performance normally the most of the industry will care, okay, is about the inference speed, meaning that what is the speed, okay, for the images to pass through your model. So because there are some industry they are very particular on this speed because they want to inspect probably 1,000 or 10,000 or 100,000 of the component within a day. So for them, speed is really constant. So either the model is take a lot of time to process, so it will make the production yield will be lesser. So that's why you yeah, this is an issue as well. Okay, so next. Okay, so just due to the time consuming, so today I think I will just cover the data and ability part, which is I don't have enough data, normally what you can do. And then if you don't have enough labeled data, and what you can do, and if you don't have a balanced data set, and what so because my current background is more on the image side, so I will talking on how normally in the workplace how I normally deal with the image data. Okay, so in terms of the type of machine learning, the conventional one, there are actually three types, namely a supervised learning, unsupervised learning, and also a reinforcement. So basically, what is supervised learning? Supervised learning basically is you train the model, basically create a model by providing the model with some guideline or some labels. So for example, like you want to train a model able to recognize whether these images should be a dark or it's not dark. So when you do the training, right, so you will provide the model with the dark images as well as the dark label. Okay, so you will tell it, these images is labeled with dark. Whereas for unsupervised learning, is actually you don't really provide labels because okay, so what you are trying to find out from this, I mean, what you want the model to help you is that you hope that the model able to learn some, I mean, some capability to help you to cluster the images. So you give it a set of unlabeled data, but you hope that the model able to help you to cluster, saying that this group of the images should belongs to one class, and then probably this should be a second class, and then this group of the images should be the third class. Okay, so this will be like that. Okay, and then so the last one will be reinforcement learning. So reinforcement learning, basically you train the machine models to make a sequence of decision. So for the supervised learning, unsupervised learning, normally you just do one time. I mean the decision only one time. Basically, I give you an image, you tell me what is the paper. But for reinforcement learning, it's actually the interaction between the agent and environment. So the agent are going to give an actions, okay, or decisions. Then this decision will going to the environment. So after it pass through the environment, right? So environment are going to provide the information back. We name it as state and also the reward. So reward it can be either I mean, if you walk in, I mean, if you perform this action, so what? I mean, will you die? Okay, let's say you play the game, right? So will you die? So if not die, then your reward will be +1. If die, then your reward will be maybe -200 like that. Okay, so in this cycle will be keep repeating. Okay, until the end. Okay, until the end. So basically, this agent is to train to make the prediction for a sequence of the decisions. So for the first challenge, which is we don't have the data, right? So we actually can solve it by using unsupervised learning, because unsupervised learning you don't require the label to train. Okay. So the method is the recent one basically is using GAN. So the GAN is called a generative adversarial networks. So this is basically the architecture. So GANs consist of two structures. First one is called a generator, and the second one is called a discriminator. So the job of the generator basically is to generate the images. Okay, try to generate a set of images based on the some input. Okay, normally we put a noise. Okay, it can be just a random noise, and then when they pass through the generator, right, they're going to produce the images. Then the discriminator, the job is actually to differentiate whether these two images are these images are whether it's fake or is it real. Okay. So for example, I generate images, and then after that I put the training data, because training set is a set of images and all of them are real. Okay. Whereas for the generator one is a set of the images that is fake lah, because you create from the generator based on the certain distributions. So that's why you will create a fake images. So when both of them are passed through the discriminator, so the discriminator must be able to tell me, oh, these images from this training set, right, it should be real. Okay. Whereas for if the images coming from the generator, it should be the fake one. So they both of them are got different objective. So the discriminator, it should be smart enough to predict whether the images should be real or should be fake. Whereas for generator, it should be learned how to fool the discriminator. Okay, to bluff the basically if the generator able to create fake images, but the discriminator saying that these images is real, meaning that the generator success. Okay, so the discriminator, the role is to just doing a discriminative job. Okay, basically I got two. So this is okay, the blue color here dots basically representing one images, and then the red one is representing another images. So what normally the deep learning do is to find a line. Okay, just to it's actually trained to form a line. Okay, so that they can separate both classes. Whereas from generator, the job is actually try to differentiate these two distribution, and then try to generate new images based on the distribution. Okay, from this distribution. Okay, so this is a application of the GAN. So like recently, probably in Facebook or in social media, you will see a lot of picture like this. So the first function, of course, they use to generate the photograph of the human face. So basically, I provide. So that's why people are saying that Facebook probably got a lot of fake images and so on. Because the back end, they're actually using this GAN technology to generate a lot of fake images, and then probably human cannot differentiate. So that's why so you need to be careful on this. Okay, so Facebook, they actually also train on the algorithm, basically train this discriminator just to differentiate whether these images is real or fake. Okay, and of course they also use for other applications as well. For example, like generate the cartoon characters. Okay, so actually I got from some of the research paper. Okay, and beside that, instead of generating the photo, okay, we also can use GAN for text to image translation. So basically, for example, I give an input like the small bird has a red head with feathers that fade from red to gray from head to tail. So if your user provide this input, right? So you want the model able to help you to generate a image. It's not in the Facebook. So basically, we use the gun, okay, to do something like this. Okay. And then of course, you also can use gun, okay, to predict the face aging. So for example, you are the age of 15. Probably you want to know what will be your face, okay, when you are age 17, 19, or 60 years old. Okay. So yeah, this is some of the capability that can be done by the gun. Okay. Okay, so now you are okay. So for the first challenge, which is we don't have enough data. Yeah, so the solution is we can use a unsupervised learning technique to solve the problem, and GAN is one of the unsupervised learning technique. Okay. And then so now we want to proceed to the next question, which is next challenge, which is if we don't have the enough label data, means we got data, just we got the images, just we don't have the enough label data. So what we can do? So what we can do is that, okay, so before we go for that, I want to tell you what is the drawback, okay, for supervised learning. So if you use a supervised learning, of course, the drawback is that you need to label the data. And label the data, the process is actually very costly. Why? Because you need to allocate time, and then you need to allocate the domain expert to tell you whether these images is bug or not, okay? And also, of course, the labeling process or the annotation process is quite long. But if you use unsupervised learning, of course, yeah, it's good thing is you don't require to provide label for learning. But the drawback is it's less accurate. Okay. So what we can do? So the researcher, okay, so what I shared to you just now is a conventional type of the machine learning or deep learning type. So it's a supervised learning, unsupervised learning, and reinforcement learning. And for the new, the researcher, they found out that these three things I cannot solve the problem that I mentioned just now. So they create another two, at least two variants, which is known as a semi-supervised learning and self-supervised learning, okay, to solve the I don't have the enough label data. Okay, so what is semi-supervised learning? So semi-supervised learning basically is an approach that combines a small amount of labeled data with a large amount of them labeled data during training. Meaning that instead of I wait for 100% label, probably I just train the model based on the 20% of my data that have been well labeled. So after I train using the 20% of the labeled data, then basically I'm able to generate the models, and then I use that model to label another 80% of the data. So after I label another 80% of the unlabeled data, then I combine the 20% of the labeled data and also the 80% of the it's a pseudo labeled data by this model you have been trained by using the originally 20% of the data, and then you train it together, so you make and then you make the prediction based on the model. Okay, so this type of method we call it a semi-supervised learning, meaning that you just train the model based on the small amount of the label data, and then you use that model to create the labels for the large amount of the unlabeled data, and then after that you create the label already, then you train it together. So yeah, this is the idea of semi-supervised learning. Okay, so this is the view in the latency. So let's say you got a few. Okay, so this one dot actually representing one images, and then you got a triangular is actually representing one images. So this is your labeled data. So okay, so this data have been well labeled already. So if you talking about you want to do supervised learning, meaning that you are trying to train a classifier. So you are trying to form a line here so that you can best separate these two classes. But if you got a group of labeled and unlabeled data, so basically because some of the data have been labeled, so that's why you got big circles and then got triangular, and then the small dot actually is the unlabeled data. And then you hope that you join this unlabeled data and labeled data, and then you are able to form a classifier like that. Okay, so this is the first type, which is semi-supervised learning. And next we got something called self-supervised learning. Self-supervised learning basically is an approach to train a model to learn the underlying structure of the data, in order to complete a task without human provide label data. Meaning that for these images, right? Okay, so you don't have label, but you can try to create some labels based on based on some data augmentation method. So for example, like okay, you try to rotate the images and then you use the rotated information as your label data. Okay, so this is one of the methods. Okay, so for example, this image X, so you rotate 0 degree, meaning that no rotation, then you make your label as 0 degree. After that, you rotate probably 90 degree, and then you say these images is rotated 90 degree. So as long as the model able to learn in the search way, they're able to tell you whether these images is rotated how many degree. So probably this model is actually learning something. Okay, it's actually learning something. So this is we call it as a self-supervised learning. Okay, so just now here is actually is yeah we are trying to on the rotations, and then next we can actually doing on the colorization. So okay, so we also can do on colorization. Basically means that we got a RGB image. Okay, so the ground truth here actually is a RGB image, and then we try to grayscale it first. Okay, after we grayscale it, right, then we let the model to learn, try to help us to predict the color. Okay, and then we compare them whether they are look the same or not. So this is the result. Okay, so I continue. Okay, next. So this is the generative modeling method. So basically, it's using it's actually using the GAN just now, the technique that I mentioned to use just now. But he tried to so for example, this is the image. Okay, you give it to the model to train. Okay, you crop some part of the images, and then you hope that the model able to learn to um try to learn. Try to learn back lah. Okay, try to fill in the pixels value. Okay, so for example, this is what your models see, and then after learning, right, probably able to fill in some of the pixels value. Okay, so next, so now I have covered the second challenge, which is we don't have the enough label data. So the third challenge is, let's say if you don't have the balanced data set, so probably you got your data have been well labeled already. Okay, just your data set is imbalanced. So the solution will be we name it as one class classification. So what is one class classification? It's actually is a special case of multi-class classification where the data observed during training is from a single positive class. So because in the supervised learning, right, you need to provide the labels, and then the label need to be at least two class, meaning that you need to tell the model whether these images is good or these images is bad, at least two class. But instead of just learning from good and bad data set, is it possible just for the model to learn the good one, and then if it is not good, then we will label it as a anomaly or it's bad. So basically, we train the model just providing one class of the image data sets, and we hope that if the images is not inside this class, right, we will say that these images is an anomaly or is not within this class. Okay, so for example, you got a set of the images like this, and you hope that you got a set of image instance like this, and then you hope that the classifier learn a circle, learn how to draw the circle, so that it will tell you, if the image fall inside the circle, then we say that this image is a positive class. Whereas if it's outside the circle, then we say it is a negative class. Okay, so this is actually the application of one class classification. So let's say we just let the model to learn. Okay, we only provide the food images for the model to learn, and then we hope that the model able to tell us, this is food and this is not. Okay, this is not means outside the food, then we say that it's not food. But it's still not able to tell you, oh, this is not food, but it is probably a cat or dog. It won't tell you, but it just tell you, oh, this is not food. Okay, and it says go to the chair. Okay, so probably you train your model with a normal chair, and you hope that the model able to learn and to tell you, oh, this chair is whether normal or abnormal. Okay, and So lastly, we actually can use the one class classification we actually can use the GAN technique, which is generative adversarial training methods. GAN stands for generative adversarial networks. So we just use a training method from the GAN for the classification purposes. Okay, one class classification. So this architecture actually named as adversarial learn one class classifier. Basically, it consists of an encoder and decoder structure, and then we got CNN structure. Okay, so and you see this one actually is quite similar with the GAN because GAN actually got two parts. Okay, we got discriminator and then we got the generator. So the job of the generator actually to create the images to fool the discriminator, whereas the discriminator it need to be smart to prevent to be fooled from the generator. Okay, so you will see, although this network is named as adversarial learn one class classifier, so it's actually a one class, it's actually for the purpose of the one class classification. But the backend technology is actually quite similar because it contains the part of generator. Okay, this part is actually the generator, and this part is actually the discriminator. Okay, so I think this is my last slide. So I would like to conclude for my sharing. Okay, so first, I introduced three types of challenge that normally you will face when you for the image task solving. So for example, you probably don't have enough data. Even you got data, probably you don't have labeled data. And then if even your data is well labeled, probably your data set will be unbalanced. So the problem, I mean the solution for the first challenge would be the unsupervised learning. Then the second challenge, which we don't have enough label data, you can use a semi-supervised learning or the self-supervised learning approach to solve. And lastly, one class solution will able to solve the problem of if you don't have the balanced data set, because you can just train on the majority class and then you will treat the minority class all as a normal or another class. Okay, so thank you. So if you want to reach me further, you can you can reach me through the LinkedIn, and of course, I actually got a blog on the Medium. Okay, I write some blog posts on the Medium, so you can have a look. So I think I open for Q&A. Just 1 minute left. Sorry. But it's like, so let me browse through the question. No question. Okay. So yeah, any question you want to ask, or is it too technical? See, no question. Okay. So yeah, if you don't have question, then yeah, probably I want to dismiss myself. Okay, so thank you for joining me.
Yeah, thank you, Beijing. So the talk has ended. Everyone can go outside to the lawn. There will be a closing ceremony happen there.